Hello students, welcome to Shri classes. We'll begin with the new chapter, chapter number 11, the human eye and the colorful world. According to your new syllabus, human eye part has been taken out, only the colorful world has been retained, and the portions pertaining to colorful world would be discussed, and the chapter flow is as below. This colorful world, we can split the entire portion into three parts, A, B and C. First one is the refraction of light through a prism, glass prism, and dispersion of white light in a glass prism. Already we have seen the refraction of light through a plain glass slab, a plain parallel glass slab, whereas we are going to see the refraction of light through a prism. And of course the prism leads to a peculiar phenomenon called dispersion that leads to the spectrum. So we'll see what is that one. Related to the same dispersion, how the rainbow is formed. The rainbow formation is also discussed under part A. Next comes part B, which is atmospheric refraction. When a ray of light enters into the atmosphere, because of the varying optical density of the atmosphere, the ray continuously bends towards the normal, and that is called atmospheric refraction. There are few phenomena: twinkling of the stars, advanced sunrise and delayed sunset, and apparent flattening of the sun's disk. These three natural phenomena can be explained by atmospheric refraction. In part C, we talk about atmospheric scattering of light, which is called the Tyndall effect. Under that, why is the color of the clear sky is blue, and color of the sun at sunrise and sunset, what is the color of the sun during the sunrise and sunset and why it is so, and also the color of the cloud we'll discuss. So this is how the entire chapter flow for the colorful world, it is related to natural phenomena, has been split into. So let us begin with refraction of light through a prism. Here, what is a prism basically? Just look at this diagram here. This prism has got two triangular bases, this one, and opposite to this is the back side. In the back side, you have one more base. So two triangular bases are there, and 1, 2 and 3. This one, that side one face, and bottom also one face. There are three rectangular faces. Three rectangular faces which are inclined to each other, and two triangular bases. So this prism basically, it is a transparent material. It is made up of transparent material like glass, consisting of two triangular bases and three rectangular faces which are inclined to each other. Let us see and here one more peculiar observation. If a white ray falls on one of the inclined faces, you can observe the dispersion over here. That means the splitting of white light into its constituent colors is observed when a ray of light passes through the prism. This is a very peculiar phenomenon. Here you can see the rainbow formation basically. So let's see, rainbow formation means rainbow like colors, okay, but rainbow is different and this is different. Here it's a dispersion phenomenon. So let us see refraction of light through a prism. For parallel refracting surfaces as in a glass slab, the emergent ray is parallel to the incident ray and is slightly displaced laterally. That we have seen already. If a ray of light passes through a plane and a parallel glass slab, the emergent ray, it is parallel to the incident ray, but there exists a lateral shift or a lateral displacement, that we have seen it. And also we have studied on what factors the lateral displacement depends upon. It depends upon the refractive index, it depends upon the thickness of the glass slab, and also it depends upon the incident angle. Now let us see what is prism. It is a homogeneous transparent refracting material such as glass. It has two triangular bases and three rectangular lateral surfaces. Lateral surfaces means these side surfaces. These surfaces are inclined to each other. The angle between its two lateral faces is called the angle of the prism. The angle between the two lateral faces is called the angle of the prism. Here, this angle is called the angle of the prism. This angle is called the angle of the prism. So, I hope you understand what is the definition of the prism. Naturally, this question appears. It is a homogeneous transparent material. Prism is a homogeneous transparent refracting material such as glass, consisting of two triangular bases and three lateral rectangular faces, and these lateral faces are inclined to each other. The angle between the lateral faces is called the angle of the prism. So this is about the prism. In next slide we will see, if a monochromatic source of light is taken, how does it bend? Here I am talking about the monochromatic source of light. Monochromatic means single color. I may take either a red color or a blue color or a violet color. Why I am referring to a monochromatic color here is, if I take a white light, you observe the splitting of white light into its component colors, and therefore it is very difficult to explain the refraction by considering all those colored lines. Instead, if we take a single, say for example, this is a red light, a red laser beam. If you make a red laser beam to incident on this surface, then how is the refraction taking place? I just want to explain. Please listen very carefully. See, if a red light is made to incident at this point on this lateral surface, then first let us draw a normal to the refracting surface AB. So this is a normal here. Normal is perpendicular to the lateral face AB. The angle made by the incident ray with normal is called the angle of incidence, which is here. This is the angle of incidence. A ray is passing from rarer medium, that is air, to the denser medium, that is glass, and therefore a ray must bend towards the normal after refraction. So a ray, instead of going straight line, it is bending towards this normal. This ray, instead of going straight line, it is bending towards this normal. That is because the speed of this ray in the glass prism decreases. Next, from here to here, the medium is the same, and therefore this ray continuously passes along a straight line. This is called the refracted ray. EF is called the refracted ray. EF is making R with respect to normal, which is angle of refraction. So PQ is incident ray, which is making angle of incidence I with respect to normal, and EF is refracted ray, which is making R an angle of refraction with this normal. Next, when this ray falls on this surface AC, let us draw the normal first at the incident point. This is the incident point. Let us draw a normal M dash. Now, when a ray of light passes from denser medium to rarer medium, it will bend away from the normal. So this line, this beam or this ray, red ray, instead of passing straight like this, it is entering from denser medium to rarer medium, and therefore this is bending away from this normal. This is a normal and this is bending away from the normal, and therefore Fs is the emergent ray over here, and Fs, the emergent ray, is making angle E with respect to normal M dash, and E is referred to as angle of emergence. So you have understood here, PQ is the incident ray, that makes an angle of incidence I with the normal. EF is the refracted ray which bends towards the normal and makes an angle of refraction R with respect to normal. And FS or FR also you can say, no problem. FR or FS is an emergent ray. When a ray of light EF passes from denser medium to rarer medium, it bends away from the normal, making an angle of emergence E with respect to the normal. So incident ray, refracted ray, emergent ray. Angle of incidence, angle of refraction, angle of emergence. Is it clear for you? And this is how the refraction of a ray of light takes place in a glass prism. Couple of another two terminologies we need to understand. This A angle, this lateral surfaces AB and AC are making here one particular angle, and this angle is called the angle of the prism. So A is the angle of the prism. Now one more thing is this incident ray PQ. If there is no glass prism, it will pass straight like this. Because of the glass prism, this incident ray has changed its direction of propagation. Finally, incident ray passed through the prism like this, and finally this emerged like this. The angle between the incident ray produced and the emergent ray produced backwards is this capital D here, which is called the angle of deviation, meaning incident ray PQ in the absence of glass prism would have passed straight, but in the presence of prism it is making an angle of deviation D over here. That means this PQ produced and emergent ray produced, if you produce backwards, the angle made by the incident ray produced and the emergent ray produced backwards is called the angle of deviation D. So the difference in angle between the incident ray and the emergent ray is angle of deviation D. So, and what else? You have some terminologies over here. PE is incident ray, okay. EF is a refracted ray, EF is a refracted ray. FS is emergent ray, FS is emergent ray. Angle A is the angle of the prism, here it is. I is the angle of incidence, this one. R is the angle of refraction, this one. E is the angle of emergence, E here. And D is the angle of deviation, D is the angle of deviation. So this is a refraction of light through a triangular glass prism. And here there is a definition of angle of deviation, important. The angle formed between the incident ray PQ produced in the forward direction and the emergent ray RS produced in the backward direction is called the angle of deviation. So the angle formed between the incident ray PQ produced and the emergent ray RS produced backward is called the angle of deviation D. So make a note of this one. So generally you may get a question, in our previous chapter, the refraction through a plain glass slab, you will be asked to draw the ray passing through a plane and parallel glass slab. Similar to that question, here also a question appears to draw the refraction through a glass prism. In that case, this diagram along with the nomenclature of all these rays along with these angles need to be enumerated or drawn, need to be highlighted along with the diagram very clearly. Then only you will get the full marks. So I hope you have understood the refraction through the glass prism, how the bending takes place. Here I am taking a monochromatic source of light. Please remember that. Next. Dispersion of white light by a glass prism. Now, if I take a white beam of light over here, then the thing is, this white light, after refraction on this face, also splits into its constituent colors, and these colors will get further separated when they fall on this surface due to refraction. See here, what is the reason that white beam of light is getting split into its constituent colors, and those colors are being separated to form the spectrum of colors over here. Okay, VI here all the colors are 1 2 3 4 5 6, 7 should be there. VIBGYOR, VI blue, green, yellow, red, yellow, orange, red, VIBGYOR, that is what we should remember. Now let us study certain phenomenon in this. First of all, if I take a white light, it is getting split into its constituent colors, and then further the colors are being separated by this phase, At this phase, refraction as well as dispersion. At this phase, only refraction, but further separation of the colors takes place. That is important. So the title for this is Dispersion of White Light by the Glass Prism. Earlier, dispersion of a monochromatic source of light through the glass prism. So let us see a couple of things which have been enumerated over here, very important. What is the dispersion? The phenomenon of splitting up of white light into its constituent colors or component colors is called dispersion. That means here I can see the dispersion is taking place, meaning the phenomenon of splitting up of white light into its constituent colors is called the dispersion. Next, spectrum. The band of colored components of a white light beam is called the spectrum. Spectrum refers to a band of different colors. Spectrum refers to the band of component colors of a white light. So this is called a band of colored components of a white light and called the spectrum. See, light is an electromagnetic wave. The entire electromagnetic spectrum consists of different waves. Here we talk about the visible range of the light. That means the visible range of the light means those colors which are the constituent colors of the white light but are visible to our eyes as called the visible spectrum or the visible range. Here if you compare the wavelength of violet to red, approximately the wavelength varies from 400 to 750 or 800 nanometers. 400 nanometer for violet to around 750 to 800 nanometer for red color. Red color, of course, wavelength is more and wavelength of violet color is smaller. That means the variation of the wavelength for violet to red is from 400 to 800 nanometer approximately. What about other microwaves, radio waves, ultraviolet rays, infrared rays and microwaves, etc.? That also is the spectrum, electromagnetic spectrum of white light, but all those are not visible to our eyes. The visible range or the spectrum that is visible to our eyes is called the visible spectrum of white light. What is the invisible spectrum of white light? Infrared rays, microwaves, ultraviolet rays, radio waves, etc. come under the invisible spectrum of white light, because see, light is a very complex phenomenon to understand. Even till today we have not understood much about the light. See, in this universe we have come across one particle which we define as a matter, but it is a massless matter. In your 9th standard definition, how did we define matter? A matter is something which has a mass and occupies space, and which is perceived by the sense organs is called the matter. But light is such a matter, of course it is visible, that's a different way which we can perceive it by sense organs, but it has no mass. So light consists of photons, which are particles but massless, but they carry enormous amount of energy. So it is very difficult to understand the property of light. To some extent we have understood, and also the light is in the form of electromagnetic wave. See, the propagation of the light is in the form of electromagnetic waves. Electrical field and magnetic field are mutually perpendicular, and those are in turn mutually perpendicular to the direction of propagation of the light. All that is different way, different things. So just we should know that the visible colors which we are seeing is called the visible spectrum of white light, which is the small part of the entire electromagnetic spectrum of white light. Entire electromagnetic spectrum of white light consists of gamma rays, X-rays, infrared rays, then visible spectrum, then ultraviolet rays, then microwaves, and then the radio waves. All these waves put together, it forms an electromagnetic spectrum of white light. But what we see over here is the visible spectrum of white light, the wavelength of which varies from approximately 400 nanometer for violet to 750 to 800 nanometers for red. The wavelength of violet is lesser, the wavelength of red light is more. That we need to remember. Okay, so we understood what is the spectrum. The band of constituent colors of white light is called its spectrum. And what is dispersion? Splitting up of a white light into its constituent colors is called the dispersion. Dispersion is a phenomenon, and spectrum is the result of the dispersion. Now, a question appears in the exam, that is, why do we get these colors? Why do we get these colors? Please remember, it is very important to understand the textbook definition, the textbook explanation for production of these colors, the textbook explanation for the dispersion. According to me, rather than the solutions from any of the reference books, I feel this textbook explanation is most important in order to explain the phenomenon of dispersion. If you look at a topper's answers, which I am going to share with you, they write absolutely perfectly even the phrases and the sentences that have been given in textbook to explain the dispersion phenomenon, that is, why do we see the colors. So can we read this paragraph here? Important. Let's see. Why do we get these colors? I hope you are able to see very clearly. I think I am not in between. This paragraph is very clearly visible for all of you. Different colors of light have different speeds. These different colored lights have different speeds and wavelengths when they travel through the transparent medium. One important point: different colors have different wavelengths and of course different speeds when it passes through a particular medium, transparent medium. But please remember, all these colors, when they pass through air or vacuum, the speed of all the colors remains same. I hope we are able to understand. All these colors, when they pass through air or vacuum, the speed of all these colors is same. But when these colors are made to pass through any medium, then definitely the speed of these colors decreases in a particular medium, because of which refraction takes place. That is bending of a ray of light due to decrease in speed when it passes from one medium to another transparent medium. Therefore, the refraction takes place and the bending of these lights take place. Now, all these different colors have different speeds in a particular medium, and therefore they bend towards the normal by different angles. So let us read the expression here. Different colors of light have different speeds and wavelengths when they travel through the transparent medium. Hence, they bend through different angles and get separated due to peculiar shape of the prism. Very interesting. Different colors will bend by different angles due to different speeds and wavelength in a medium, and these colors get separated further due to the peculiar shape of the prism. These are the two answers for which, if a white light passes through a prism, a phenomenon called dispersion is observed. I hope you understand. So, this particular first bullet very clearly explains the splitting up of a white light into its constituent colors and also further separation of the colors to produce something called a visible spectrum. I hope you have understood. Question arises, why red bends least and violet bends most? Do you understand here? If you find the angle of deviation with respect to the incident ray, the red light angle of deviation is least, the violet light angle of deviation is most, and therefore red light deviates least, violet light deviates most. Why it is so? Simple. Red light speed is more and refractive index is inversely proportional to the speed. More the speed, lesser the refractive index of this color with respect to this prism and the air. Lesser the refractive index, it bends less towards the less away from the normal. Whereas violet, the speed of violet is least, refractive index is most, therefore it bends most, because refractive index is inversely proportional to the speed. Do you understand that? So if required, I will just try to explain that on the board also, but let us see here. So why the red bends most and violet bends least, I explained. The same thing is written here. The red light bends least because it travels faster, and the violet light bends most because its speed is least. Okay. See, after all, the bending phenomenon is governed by the refractive index. More the Ri, more is the bending, either towards the normal or away from the normal. That we should keep it in mind. So that means lesser the speed, more is the bending. Refractive index is inversely proportional. For example, how do you conclude that? How do you find that whether it is inversely proportional? Mu m, refractive index of the medium, is equal to C by Vm, where C is the speed of the light in the air or vacuum and Vm is the speed of the light in the medium. So mu m is inversely proportional to Vm. More the velocity of a particular color, less is the refractive index of that color with respect to prism, and therefore less bending. Smaller the speed, more is the refractive index of that color with respect to prism. More the refractive index, more is the bending. And therefore this second bullet explains why the red light bends least and the violet bends most. Speed of the red light is more, hence refractive index of red light with respect to the glass prism is least, and therefore it bends least. Speed of the violet light is more, refractive index, speed of the violet light is less, and refractive index of the violet light with respect to glass prism is more, and therefore it bends most. Last, thus rays of each color emerge along different paths. That means different colors will emerge along different paths and become distinct to form the spectrum, and they become distinct That means those will get separated due to the peculiar shape of the prism. Dear students, one important point here, production of the spectrum is due to a peculiar shape of the prism. If I take a white light and put a parallel glass slab, do you observe these colored components? Think over and you answered me. You have to answer that question to me. Okay. So here the separation of the colors, the splitting up of the colors into splitting up of white light into its constituent colors is called dispersion, and further those colors will get separated due to peculiar shape of the prism, and this is splitting up of the white light into its constituent colors is due to the change in speed, the different wavelengths and the difference in speeds of just a minute. Different colors of light have different speeds and different wavelengths. Yeah, different colored of light have different speeds and different wavelengths, and hence these individual colors will emerge along different paths at different angles, and therefore we observe the dispersion, and due to peculiar shape, the spectrum. I hope you have understood. Please go through this thing. You can make a note also. You can pause the video. In earlier cases also, you could have paused the video and noted down. Every time I did not tell about that, you yourself have to decide what are the points to be noted down, and pause the video and note down those points. So we have understood a dispersion of white light by a glass prism. What is the dispersion? What is the spectrum? Why the colors? Why do we see these colors? I hope till now you have understood very clearly. Next. This is a very peculiar thing here. Recombination of spectrum of white light. Recombination of spectrum of white light. Here, the title of the diagram is recombination of spectrum of white light. Newton performed this experiment. What did he do? Isaac Newton, what did he do? He took one glass prism and made a white light to pass through. He observed the spectrum. That means he observed the spectrum over here, that is splitting up of white light into its constituent colors. Then what did he think? He thought, as these colors are getting separated, he took one more prism and placed in the same fashion, not inverted prism, the same prism he took and placed over here, to understand whether these red VIBGYOR, do these colors have further more colors or not. He wanted to test that one. When one more glass prism was placed over here, those colors got deflected once again, but no more colors could be produced. He concluded that a white light consists of 7 component colors. Then what he did, he inverted the prism in this position now, and he placed at this point where the spectrum is observed. Surprisingly, all these VIBGYOR 7 colors, when they were made to pass through this inverted prism, he could obtain once again the white light. And interestingly, this white light and this white light were parallel to each other, but there was a lateral shift. Why it is so? If we join these together, that means this phase and this phase is parallel to each other. Therefore, this will becomes a parallel glass slab. If I combine these two prisms, the same identical prisms, okay, very important is these two identical prisms. When we combine these two on lateral faces together, then this is parallel to this face and this is a glass. So it becomes a plain parallel glass slab. In that case, the white light undergoes a refraction, and the emergent ray and incident ray, those are parallel to each other, shifted. Lateral displacement exists. So he concluded that the white light consists of 7 constituent colors, and all those seven colors combined together once again to produce white light. Based on this experiment, he could conclude that white light consists of only 7 component colors. So the description is given over here. You can read yourself. Now generally one question appears on this one. He explains Sir Isaac Newton's experiment to demonstrate that a white light is a constituent of 7 component colors. So in order to do that, this experiment needs to be explained. You can read this one and also make a note of this one. Now here I am going to read one question. State the cause of dispersion of white light by a glass prism. How did Newton, using 2 identical glass prisms, show that white light is made up of 7 colors? Draw a ray diagram to show the path of a narrow beam of white light through a combination of 2 identical prisms arranged together in inverted position with respect to each other, when it is allowed to fall obliquely on one of the faces of the first prism of the combination. This is a question that appeared in previous year. What would be your answer for this question? State the dispersion of white light by a glass prism. That means, why do we observe 7 constituent colors when a white light is made to pass through a dispersion, made to pass through a glass prism? That question needs to be answered. And second part is Newton's experiment needs to be explained along with 2 identical prisms and a white ray and a white beam of light when it obliquely falls on one of the lateral faces of the glass prism. So how do you write it? Now I'll show you how the topper has written and who has got full marks, and you can just see the comparison of his answers with my previous slide, which was almost similar to the textbook paragraph. So let us see the topper's answers. See here, the topper's answer question, answer 17. I hope it is better to focus a camera on this. I will read this for you. I also have to learn a lot of things from this topper. So nicely it is written. Let us see how he has written, dear students. Cause of dispersion of white light by a glass prism. One arrow he has put and there is an answer. What is that? When white light ray passed through a glass prism, its constituent colors having different wavelengths and speeds bend or deviate at different angles, due to which they get separated from each other. What is the meaning of this one? The white light, when it is made to pass through a glass prism, its constituent colors, which have different wavelengths and speeds, bend and deviate at different angles, due to which they get separated from each other, is the answer. Excellently written. Read 2-3 times, then you can understand the how he has made a network of those sentences or the words basically. This particular phenomenon happens due to peculiar shape of the prism, that different colors go in different directions. That means due to peculiar shape of the prism, further the constituent colors get separated in different directions. This is the answer for cause of dispersion of white light by a glass prism. Meaning, important, there are 2 points involved in this answer. One is, different colors of the white light have different wavelengths and speeds, and therefore they bend or deviate at different angles when a white light is made to pass through a glass prism obliquely. And second thing, due to a very peculiar shape of the prism, these different colors will get further separated to produce a spectrum, and this is the cause of the dispersion, is what he has written. Next, Newton's experiment. Let us see. First look at the diagram. This diagram, P1 and P2, incident ray, R and V. You need not show the entire spectrum over here. Violet, indigo, blue, Vi, Bg, Yu are not required, because this is a schematic sketch and need to be very precise. Dear students, If some of your teachers insist that you need to mention all these different colors, not required. It is absolutely not required. Look at the topper's answer. Go and show this paper to your teachers. Okay, it is very good here how he has represented. So incident ray, V, it is written over here. I hope you are able to see. This is violet and this is red. Further this will get deviated. This also will get deviated slightly, and there is an inverted prism, and here band of 7 colors he has written. Yes, here we observe the band of 7 colors. Now when these band of 7 colors fall on this face, this will bend further and further. This also will bend like this and this further. Here very important is these two rays will join together over here and finally it comes out. And this is the recombined light. This is a recombined light. Incident white light, R and V, band of 7 colors, R and V, and finally recombined light. This diagram is perfect. You can check your textbook. So let us see how he has written the experimental explanation and observation. Newton passed a ray of white light through a glass prism. After refraction, the white light splitted, he said. Okay, sometimes he was splitted and split, it's okay. The white light splitted into its constituent band of 7 colors called spectrum. When he tried to further split it by placing a prism, it didn't occur, but when he placed the inverted prism and passed the band of colors through it, he saw white light ray coming from the other side. Thus he concluded that sunlight is made up of 7 colors. Here also you can say the white light is made up of 7 colors. He could have simply said, he concluded that the white light is made up of 7 colors. But anyway, sunlight was the experimental during Newton's experiment, he took the sunlight itself, and therefore of course there is nothing wrong in writing a sunlight because it's a white light only. Sunlight is made up of 7 colors. So this is the explanation, but I am sure my students, all of you can write much better than this. I am pretty sure you should be able to write much better than this. That means you also can visualize yourself to be in the topper's position. Definitely it is possible. Okay. So only thing is reading question carefully and splitting your answers into different parts according to the question asked, and writing with proper explanation without much scratches and all. You know, it's a quite good explanation over here by the topper, isn't it? Okay, fine. So we answered one question also and went through the topper's answers. Next we'll see the rainbow formation. First I will explain to you over here, and then rainbow formation. A rainbow is a natural spectrum appearing in the sky after a rain shower. Here you can see a rainbow formation. So a rainbow is a natural spectrum appearing in the sky after a rain shower, generally after a rain shower. A rainbow is always formed in a direction opposite to that of the sun. Remember, the rainbow is formed opposite to the direction of the sun. How the formation of the rainbow takes place? First of all, the water droplets which are present in the atmosphere due to rain, all those water droplets act like prisms because it is making a dispersion. The water droplets are able to split the white light and deviate those 7 constituent colors towards us, and therefore we see a spectrum, natural spectrum of 7 colors. That means each and every droplet would act like a prism. So what happens inside a prism, we'll see here. There are 3 points I have marked here. This is a water droplet. A, B and C are the 3 places where we need to study different phenomena. At A, when a white light falls on this water droplet, it will split into its constituent colors. V, R. R bends least, V bends most. R is on the top, V is on the bottom. So at this surface, the bending phenomenon of the light is observed and splitting phenomenon is also observed, meaning at point A on the surface of the water, refraction took place and dispersion took place, or refraction and dispersion both takes place at point A. So at A, refraction and dispersion took place. Refraction refers to the bending phenomenon of a ray of light, whereas dispersion refers to splitting phenomenon of a ray of white light into its constituent colors. Now the back surface is acting like a mirror over here. What it will do? It will reflect red color and violet color, and therefore at point B on the back surface of the water droplet, we say the reflection is taking place. But what kind of reflection? This is internal reflection, because the reflection is taking place inside the water droplet, and therefore at B, internal reflection is taking place. Here it obeys the laws of reflections, that is, the angle of incidence is equal to angle of reflection. Now coming to this face over here, once again the red light and the violet light are the monochromatic source of lights basically, and at this surface the bending takes place. That means light travels from, the ray light travels from denser to rarer medium. So again the refraction takes place. At surface C, at point C on the surface, only the refraction is taking place. Red light bends, violet light bends. So there are three phenomena at three different positions on a water droplet. At position A, refraction and dispersion takes place, and at position B, internal reflection takes place. At position C, refraction takes place. Because of these three natural phenomena taking place at three different positions, the observer who is over here is able to see the red light on the top and the violet light at the bottom over here when the rainbow formation takes place. Like if the rainbow formation takes place, the red light is on the top and the violet light is at the bottom. So this is how one can see the visible spectrum, which is the natural spectrum, that is the 7 constituent colors of the rainbow can be seen. I hope we are able to understand what are the different phenomena. So a question appears, explain the formation of a rainbow. The water droplets act like small prisms. They refract and disperse the incident sunlight, then they reflect it internally and finally refract it again when it comes out of the raindrop. Due to the dispersion of light and internal reflection, different colors reach the observer's eye, thus the rainbow formation takes place. This is the explanation for formation of the rainbow. What are the necessary conditions for rainbow formation? There are two conditions very important. The presence of water droplets in the atmosphere, and the sun must be at the back of the observer. Here, if I am observing this phenomenon over here, the sun should be behind me over here, and therefore rainbow formation takes place opposite to the direction of the sun, and hence we say over here sun must be at the back of the observer if the observer is seeing a natural spectrum. Okay, these are the two conditions which one has to understand. So make a note of all these points, and this at positions A, B and C, the natural phenomenon that occur is also written over here. The diagram, the brief, the phenomenon and the rainbow formation, why it is forming and what are the necessary conditions. So make a note of this all. Pause the video and make a note. So dear students, today we have understood refraction of monochromatic source of light through a glass prism, the phenomenon of dispersion, production of visible spectrum. What is the definition of a dispersion and a spectrum. Why do we see the constituent colors? And finally, how the rainbow formation takes place. Part A is complete. Next, Part B, atmospheric refraction, and the natural phenomena due to atmospheric refraction are apparent star position, twinkling of stars, advanced sunrise and delayed sunlight. These three topics along with the explanation of atmospheric refraction will be taken into my next class. So for the time being, let us end the lecture. Go through the PPTs, make a solid notes and watch again and again, and also read the textbook to master this one. So see you in the next lecture with atmospheric refraction. Thank you very much for watching.